Hello guys! We continue going over examples of particles with externally applied forces and acceleration that are solved based on Newton's laws of mechanics. This example is example number 2, which states the following. Find the acceleration when a particle of mass 1.5 kilograms is acted on by a resultant force of 6 newtons. So let's illustrate this statement with a sketch. There's a particle of mass 1.5 kilograms. This is the mass of the particle. There's also a resultant force acting on this particle with a magnitude of 6 newtons. This resultant force is unidentified, where it's not mentioned what type of force it is or the direction of its force vector. We're just given its magnitude, which is a resultant of all forces acting on this particle. So the resultant force is 6 newtons. And we're asked to calculate the acceleration of the particle that it acts on. Then, having the mass of the particle and the resultant force acting on it, we can directly use the equation of Newton's second law, where the resultant force F is equal to the mass of the particle multiplied by its acceleration. So F is equal to m multiplied by a. It's equal to ma. Then to calculate a, we divide both sides by the mass m. So we end up with F divided by m is equal to ma divided by m. We cancel out m at the right side, then the acceleration a is equal to F divided by m. So we can directly calculate a, that's equal to F divided by m, but this was a demonstration to understand the derivation of the formula of the acceleration a. So the resultant force is 6 newtons and the mass is 1.5 kilograms. Then 6 divided by 1.5 is equal to 4, where the unit of acceleration is meter per second squared. Then the acceleration of the particle is 4 meters per second squared. Again, this example demonstrates how we can calculate the acceleration of the particle knowing two given values. One is the magnitude of the resultant force acting on the particle, and the other is the particle's own mass. The direction of the resultant force vector is not given, neither that of the acceleration vector. So we directly use the equation of Newton's second law to calculate the magnitude of the particle's acceleration as the magnitude of the resultant force acting on the particle divided by the mass of the particle.